Hello everyone, welcome to my chemistry channel BL the Short and Sweet in Chemistry. Now I am going to explain the topic that is short revision of chemical reaction in organic compounds, especially involved in class 11th. Now here the topic based on the alkyne, the reaction involved in the chemical properties of alkyne. This is the part 14. In part 13, I have explained the chemical reaction involved in the preparation of alkyne. Different methods are there, what I have explained in part 13. Now I will see here the chemical properties of alkyne. What are the reactions involved? So many reactions are there according to nature of the alkyne and triple bond of alkyne. What is alkyne? Alkyne means triple bond. That means it is an unsaturated hydrocarbon where it contains 3 bonds, that is triple bond. Out of triple bond, what are the bonds? One is sigma, other two are pi bond. Now you can see here what is the hybridization involved. I have explained in a hybridization chapter what is the hybridization in ethine, that is sp hybridization. Sp hybridization means sp hybrid orbit of this carbon, sp hybrid orbit of this carbon which gives sigma bond. And here also CH, that is sp hybrid orbital of carbon, and here s orbital of hydrogen which gives sigma bond. Here also same sp hybrid orbital of carbon and s orbital of hydrogen which gives sigma bond. Now these two are pi bonds, only lateral overlapping of py pz, py overlapping, pz overlapping. This gives, that is mean here you can see py overlapping and another is pz overlapping, and this is gives that pi bond. And you can see when sp hybridization takes place, that is what happened. S character is 50%, S character 50%, P character 50%, but carbon is the highest electronegative here character. That is why here it shows that acidic nature. Alkyne always shows acidic nature. Then how can you prove it? That first you use sodium metal. With sodium metal, if you treat sodium metal and here ethine, both sides contain one hydrogen atom. So one hydrogen atom react with the sodium gives, that is C minus Na plus, because C is electronegative. That means here half hydrogen atom. And what is this? That is called sodium acetylide, or you can say sodium ethinite. Now you see there are other hydrogen atom is present here. If other hydrogen atom present here, then what to do? This also should react with sodium, then treat sodium. Then this hydrogen is replaced by sodium. Then you can see both sides are sodium atom, there is no hydrogen atom, and that is called disodium ethinite and plus hydrogen H2. Now if I say propyne, first is ethine, next is propyne, butane, like this. So propyne mean here you take sodium, NaNH2, sodium amide. What is that one? Sodium amide. If you treat sodium amide, then what happened? Again out of 2 hydrogen, but there is only 1 hydrogen possible because other side is CH3 group. There is no free hydrogen atom here. So it gives CH3, C triple bond, C Na plus, NH3. Sodium propynite, because it is the structure of propyne where one hydrogen replaced by CH3, other hydrogen replaced by sodium propynite. Similarly, if you take acetylene, that is ethine, and you take sodium amide, same, both sides hydrogen one by one displaced, and it gives the same product, that is NaC minus, triple bond C minus, Na plus. That means here you can say disodium ethinite is produced. I think it is clear the acidic nature of ethine, that is sp hybridization, due to that 50% character of S character. That is why it is acidic nature. You can prove by the help of sodium amide and sodium, where it gives sodium propynite, sodium ethanol. Now we will see what is addition reaction in alkyne. After acidic character of of alkyne, we will see the addition reaction of alkyne. In addition reaction, there is very important part of the alkyne. Now see, suppose this is an alkyne and X2 is added, which is electrophile. Then here first step, triple bond changes to double bond, and to that X is attached, and here plus X2 again react. You can see here in one position the two X are attached, in two position the two X are attached. That means 1 1 2 2 tetra derivative of alkyne is produced. Let us see one example, addition of dihydrogen. If I say hydrogen, it may be confused about H. That is why dihydrogen means hydrogen molecule. If the catalyst should be used, if the catalyst is not used, that means reaction is not going to complete. That is why palladium and nickel or you can take place and hydrogen is added, then it changes to ethene. That means triple bond changes to double bond, again you add hydrogen, double bond changes to single bond. You know double bond means it is ethene and single bond means it is ethane. When two hydrogen are one by one, alkyne changes to alkene, alkene changes to alkane. Similarly, if you take propane, where triple bond is there and about 3 carbon, and after adding hydrogen in presence of nickel catalyst or palladium catalyst, it changes to propene, propene again changes to propane. Now similarly, butene, that means both sides are CH3 are there is no hydrogen free, and that means here triple bond changes double bond, that means butene changes to butene, triple bond changes to double bond butene, and butene again addition of hydrogen in presence of catalyst, it changes to butane. Again you can observe triple bond changes to double bond changes to single bond, triple bond means alkyne changes to alkene, alkene changes to alkane. You can observe here wine changes to in, next changes to n, alkyne, alkene, alkane. Everywhere you can see here, that means alkyne changes to alkene, alkene changes to alkane by the addition of dihydrogen. Next we will see other addition reaction just like halogen and halogen acid, etc. Next reaction of addition reaction. That means addition reaction of alkyne, first is hydrogen and second one is addition of halogenation, addition of halogen, that is called halogenation. Now see here, let us here, this is propane. See here 3 carbon triple propane plus bromine, then what happened? Between triple bond, what are the bonds? One side carbon, other side CH. So first step, one bromine here attached, and triple bond changes to double bond. Plus bromine, again you will see here that compound is double bond changes to single bond, double bond changes to single bond, and here one bromine is attached and double bond changes to single bond. Then what is the last product? 1 1 2 2 tetrabromopropane. This is 1, this is 2, this is 1, this is 2, 1 1 2 2 tetrabromopropane, because the structure of the hydrocarbon is propane. So 1 1 2 2 tetrabromopropane, and here it is 1 2 dibromoethene. Ethene is the main house where main hydrocarbon, where one position one bromine is attached and second position one bromine is attached. So it is called 1 2 dibromoethene, and it is called 1 1 2 2 tetrabromoethene. Propane. It is not ethane, it is 1 2 dibromo, very sorry, this is not ethane, this is propane, because 3 carbon. So it is 1 1 2 2 tetrabromopropane, here 1 2 dibromopropene, because double bond, so it is propene. Now it is clear. Then come to, suppose you want to add chlorine, and here in the chlorine you require one other solvent, that is CCl4, carbon tetrachloride. here one bromine, here one bromine, and this is the house of ethyne. So one bromo, it is the house of ethyne, it is the house of ethene. 1, 2, this is 1, this is 1, this is 2. 1, 2 dibromo ethene, and again chlorine, sorry, it is not bromine, it is chlorine, so it is chlorine. So 1, 2 dichloro ethene. Similarly, again you are chlorine, again 1, 1 tetrachloro, 1, 1, 2, 2 tetrachloroethene. This is Cl, 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 Cl. Also, actually it is chlorine, not bromine, but by mistake it is written as bromo. So what is then? CH111CH, chlorine is added, so here chlorine, not bromine. Here also chlorine. So name is 1, 1, 2, 2 tetrachloroethane. Here it is 3 carbon tetrabromopropane. And next is addition of halogen acid. Addition of halogen acid. See, this is plus part, this is minus part. One is plus, one is minus. Everywhere plus, minus. So what happened here? When you add this one, you will observe whether it is symmetrical hydrocarbon or unsymmetrical hydrocarbon. What is mean by symmetrical hydrocarbon? If the between double bond, both sides, if the number of carbon and hydrogen atoms are same, that is called symmetrical. Again, see, if in between triple bond, if the number of carbon hydrogen same, that is called symmetrical. If different, this side 2 carbon, this side 1 carbon, that is called unsymmetrical. Now it is symmetrical. For symmetrical, no rule is followed, and here after that we will see in insymmetrical what happened, what is the rule, that is called Markovnikov's rule followed, but here now no rule will follow. So that is why you see triple bond mean, here you will see you add hydrogen here and bromine here, or bromine here, hydrogen here, no problem, and now it is called CH2CHBr. Okay, so here one H and one Br you will add, that is called bromoethane. Again if you add again HBr, again there is a double bond, so between double bond one H here, one Br here you will put, and that is called here CS there, and here HBr is added, so CS3 there, and here is one bromine here and one bromine here. Clear now? Because bromine is added and hydrogen is added, hydrogen will come to here and bromine will come to here. Then what is the name? Bromo here, 1, 2 carbons, so bromo. What is bromo? 1, 1, 1, 1, 1 dibromoethane, dibromoethane, dibromoethane. Again see, it is 1, 1 dibromoethane. So see again, CH triple bond CH HBr. So here what happened? Br comes to here, H comes to here, then it is bromoethane. Bromoethane, if HBr is added, since hydrogen this side is adding, so CS3, and this side is HBr, so H here, Br here. So you can observe 1, 2, 3, 4. That means valency of carbon satisfied. So here CS3, C, Br, BrH. Then what is the name? 1, 1 dibromoethane. Bromoethane and dibromoethane, because it is single bond, that means alkane. So it is 1, 1 dibromoethane, and simply ethane. Again see from the beginning, again I want to explain here propyne and 2 bromine, so here 1 bromine, here 1 bromine, and if you are not satisfied, you can see the bonds are satisfied not by the carbon. 1, 2, 3, 4, 1, 2, 3, 4. Okay, then again bromine is added, so here 1 bromine, here 1 bromine. What is the name? 1, 1, 2, 2 tetrabromopropane, because you see how many carbon? 3 carbon. And now if it is ethyne and it is chlorine and solvent is equal to CCl4, very important. And here one chlorine is added. Then after that, here you can see another chlorine, where this chlorine here attached, one chlorine attached, that is 2 tetrachloroethane. Then come to addition of halogen halide. Halogen halide, that means hydrogen part is positive sign and that is halogen part, that is negative sign. Then how it is added? It is symmetrical alkane where both sides you can obtain same number of carbon, same number of hydrogen there, and HBr. So here hydrogen and here Br, that is bromoethane. Now if HBr is added, again here one hydrogen, here one carbon. So sorry, one bromine here, one hydrogen here. Then what is the name? CH3, CH, and there are 2 bromine in one position. So what is the name? Here it is 1,1-dibromoethane. Are you clear? I hope it is clear. And it is 1,1-dibromoethane. It is bromoethane because there is a double bond, because there are single bond, and C carbon, the bond 4 valence is satisfied. And what is the name? 1,1-dibromoethane. I hope it is clear. And after that you will see what is the difference between symmetrical alkyne and unsymmetrical alkyne, and how the addition of hydrogen halide that takes place. We will see in better some other examples. Now we will see the addition of hydrogen bromide in unsymmetrical alkyne. Then what do you mean by symmetrical, unsymmetrical alkyne? Symmetrical alkyne means within triple bond both sides carbon, hydrogen same. And here unsymmetrical means within triple bond both sides carbon, hydrogen are not same. Example, propane, you can observe here triple bond, 1 carbon, 2 carbon, 3 hydrogen, 1 hydrogen. So when you take HBr and R, then what happens? H is plus and Br is minus. So it changes to CH3, Br, double bond CH2. What is the original house here? What is the original hydrocarbon is there? That is propane. And here bromine is attached in 2 positions. So 2 bromopropane. And if you are HBr again the bromine will come to 2 position because there is no hydrogen present. That is why here it is 2,2-dibromopropane. Then come to addition of water. That is called hydration of alkyne. And here what happened? You require HgSO4 and dilute sulfuric acid. When you take dilute sulfuric HgSO4 and it is a symmetrical alkyne, that is your ethyne, what happened? CH2 double bond remain, COH is attached, and here hydrogen remain as it is. That is the enol position, that is called enol group. And tautomerize, it gives acetaldehyde, that is keto group. So what is the last product here? Acetaldehyde. Sometimes you can write directly also this plus this equal to acetaldehyde. Then we will see the other reactions of alkyne. If you see addition of water in unsymmetrical alkyne, that means what is the result? And when water is added, and here dilute sulfuric acid and mercuric sulfate is required. Now see, the propane is the your unsymmetrical alkyne because both sides carbon and hydrogen number are different. And here what happened after adding water? This gives OH here and H here. Then see what happened. This when tautomerize. When it tautomerize, what happened? The OH H will come to here, O remain here, and that is called propanone. It is enol form, and here it is propanone is keto form. That means you can see this is the last result. Again see, propane when treated with this with water, then what happened? It gives propanone. This is enol form and this is keto form. Here the keto form is the important, so it is the keto form, it is the enol form. And you see, if addition of hypohalous acid, what is hypohalous acid? And here the X part is positive and OH part is negative. Now what happened, you should remember X part is positive and OH part is negative. Then what happened here, it gives CHOH double bond CHCl, because here OH is added this side and Cl is added this side, and now I told OH is the because it is symmetrical, no Markovnikov rule required. Simply you are, as you are with this side OH, this side Cl, or this side OH, this side Cl, it is depend on you. And after that adding, what happens, since one OH is this side, that is why again OH also come to this side only. And now with one carbon, if two hydroxyl groups are there, that is unstable. It is unstable. Since one carbon having two hydroxyl group, so it is unstable. Water molecule removed and it changes to keto group. See, this is the position 1 because it is CHO, C carbonyl group. So not keto, sorry, it is H is there. So carbonyl group, that is aldehyde. And here CH, that means in one position aldehyde group and second position there are two chlorine. Then what is the name? 2,2-dichloroethanol. Ethanol means the IUPAC name of that is your aldehyde, acetaldehyde. So the name is dichloroethanol. And what are the position of chloro? 2, 2. So, and next come to propyne. Propyne is the unsymmetrical hydrocarbon when you follow the that Markovnikov's rule. I told Markovnikov's rule means the negative part will go to the carbon which contain least number of hydrogen. Now you can see the carbon where it contains, here contains, that means no hydrogen. So this here the OH group will come to here. This is the CH3, COH and CHCl. Now there is a double bond, that is why HOCl is added again and OH come to here and Cl come to here. I told with one carbon, if there are two hydroxyl group, that is very unstable. That is why one water molecule should be removed, minus water. So OH, water removed. Then what is remaining? CH3, C double bond O, CH, Cl, Cl. That means 1,1-dichloropropane. Again see, from the beginning propyne is unsymmetrical. So when water is added with this reagent, then what happens? Tautomerase takes place and lastly propanone we are getting. Additional hypohalosynthesis where OH is the negative part, X is the positive part. So if HOCl is added to symmetrical, there is no problem. You can add OH here or Cl and Cl here and OH here. It is your choice. Now what is the product? Is one side OH is there, that is why if add again HOCl, OH will come to this side. I told with one carbon, if there are two hydroxyl groups, that is very unstable. One water molecule removed and aldehyde group is produced, and that is called 2,2-dichloroethanol. Similarly, if you take propyne which is unsymmetrical, HOCl, here you follow Markovnikov's rule. The negative part come to the carbon which contain least number of hydrogen, here OH. Again HOCl, again this carbon 2H, and now it is 1,1-dichloropropane is produced. Now up to here the addition reaction is going to complete, but there are so many reactions, other reactions which are also very important part, just like oxidation, ozonolysis, polymerization, like this, the other reactions are there. I hope after this in a coming video I will explain the other reactions. Hope you will subscribe my channel BL Das Short and Sweet in Chemistry. Try to read all the things, all the reactions very well, so that in 12th class you will very much interested to read the reactions of 12th class. So it will be very easy also when you read 12th class chapter Organic Chemistry. So in coming video I will explain the other different type of reaction. Thanks to all for watching my video. Thanks again to all.